So in this lesson, I would like us to look at curve sketching. Curve sketching. So in this, we are sketching curves. Now, you know very well that when we talk of a sketch, when we talk of this sketch, it must not be the whereby you plot all the points. In sketching, you choose some few points which are very key. For example, in our sketching, we are sketching the curves, and therefore you choose some very important points in a curve, and then you are able to sketch. In sketching, you must not sketch in a graph paper. You can sketch in a plain paper because you only show the very major points. And therefore, we say that a sketch of a curve, a sketch of a curve shows the shape. It shows the general shape. It shows the general shape, and maybe other important features, of a curve. So a sketch of a curve shows the general shape and other important features of a curve. Now, in sketching the curve, we are going to consider the intercepts, that is both the x and the y-intercepts. We also need to consider the turning point. So we will consider, that is in sketching the curves, we will consider one, the intercepts. Where does the curve cut the y-axis and where does it cut the x-axis? Then number two, we'll also consider the turning point. It can be one or two, that is depending with the curve equation. Then number three, what also we require also to know the nature of the turning point, or the nature of the stationary point. Nature of the stationary point. Is it a maximum? Is it a minimum? Or is it a point of inflection? So a sketch of a curve shows the general shape and other important features of a curve. And we consider when sketching the intercepts, that is both the x and the y-intercept, the turning point or points. We also consider the nature of the stationary point. Now, I'd like us to do an example whereby we are going to sketch a curve. So in this, we are told to sketch the following curve. Sketch the following curve. Sketch the following curve, and the equation for the curve is y is equal to 3x squared. I want us to sketch that curve. Now that we have covered all this, whereby we were looking at how we can get the stationary point, the nature of the stationary point, then this is very easy to sketch the curve. So we are going to follow these three: the intercept, the turning points, and the nature of the turning point. Then we sketch. So we are going to sketch the curve y is equal to 3x squared. So I want us to start with the intercepts. We need to get the intercepts. The intercepts, that is the x-intercept, and also the y-intercept. So we can start with the x-intercept. The x-intercept is the point where the curve cuts the x-axis. So if we have the axis this way, where it will cut the x-axis, this is what we refer to as the x-intercept. And when we want to get the x-intercept, the value of y is 0, because at any point here on the x-axis, the value of y is 0. So our y is equal to 0. So we get the x-intercept, whereby in that case, the value of y is equal to 0. So we simply come and say our curve y is equal to 3x squared. Our y is 0 is equal to 3x squared. We can divide by 3 by 3. So we get that x squared is equal to 0. And therefore our x simply will also be equal to 0. So therefore we have the x-intercept whereby our x is equal to 0, and again our y at that point is equal to 0. Again now we come and get the y-intercept, the y-intercept. On the y-intercept again, if we have our Cartesian plane this way, a line that will cut any point, that is the y-intercept at this point, our y-intercept is that this point or this or any other on the y-axis. And therefore it means that at any point on the y-axis the value of x is 0, because our point here is 0. So any point will be 0. So on the y-intercept, therefore our x is equal to 0. So when we get now, we come and get the value of y. So we have the equation y is equal to 3x squared. Our y is equal to, our x is 0. 0 squared times 3, we get 0. And therefore, for the y-intercept, we have 0.0 for x and 0.4 for y, we have 0. So we have 0, 0, 0, 0. That is the origin. So we have x-intercept and also the y-intercept. Then we move on and get the turning point. The turning point. In our case, the equation, so we are now in the turning point. Then we are going to sketch the curve, the turning point. We know that at the turning point or at the stationary point, the gradient is 0. And therefore, if we have our equation 3x squared, therefore, the gradient dy all over dx should be equal to 0, which is dy all over dx is equal to, this is for the stationary or the turning point. This is for a stationary point. So we have, when we differentiate, we get 2 times 3, that is 6, x raised to power 2 minus 1, which is 6x. So our gradient is 6x. So 6x is equal to 0 at stationary point. So when we divide this by 6, we end up getting that our x is 0 over 6, that is 0. And therefore, we want to get the turning point. This turning point, therefore, will be y is equal to 3x squared. Therefore, we have our x as 0, therefore y will be 0 squared times 3, that is 0. So the turning point is, or that stationary point, therefore, will be, the stationary point is, we write the stationary point. So the stationary point, or our turning point is, therefore, for x we have 0, y 0. Then we move on, finally, the nature of the stationary point. So we just come and get the values here of x, then the gradient at x, so that we can see the nature. Gradient at x. So we have, when the gradient is 0, our x is 0, when the gradient is 0. So we get a point towards the left and towards the right. So we get the gradient at x. And we know that the equation for the gradient dy all over dx is equal to 6x. 6x. So we have negative 1 times 6, negative 6. 1 times 6, we have 6. So we have negative, and then we have 0, then positive. So we have our negative, we have 0, and we have positive. This is negative gradient, this is 0 gradient, this is positive gradient. And therefore, our curve should, the turning point or the stationary point should be a minimum. Now we can come and sketch that curve. We sketch, now we have the intercepts, we already have them here. This one and this one, we already have the turning point, which is 0, 0. We also have the nature of the stationary point, which is a minimum. So we just come and sketch now We've said you can even sketch on a plain paper, because a sketch will only show, it shows the general shape of the curve and any other important feature on that curve. So we can come and simply sketch it, so that we know that our intercept, we have 0, 0, 0, 0, so it is through the origin. Again, the stationary point is 0, 0, meaning that, and we have it as positive. So the only point that we have is this point, that is 0, 0. Because for the y-intercept, the x-intercept, we have it as 0, 0, and 0, 0 is the origin. It's simply the origin. This is again the origin. Again, the stationary point is at the origin. The stationary point is here at the origin, meaning that because it is a minimum, therefore it simply means that that's our curve. That's the sketch that we have. So that's the sketch for the curve. It is a minimum, the minimum, and we can see that it is at 0, 0, and we have any other point at that point. So the x-intercept, 0 origin, again the origin, so we have it that way. That is the sketch for the curve. Then we can do another example, example 2. Again, we are sketching. I want us to sketch another curve. So example 2, sketch the following curves. Sketch the following curves. Sketch the following curves. And I want us to sketch one more. The equation is y is equal to x cubed. Y is equal to x cubed minus 3x squared. 3x squared. And I want us to follow the same procedure. With the first one, it is very direct because everything is 0, 0, 0, 0, and we know that it's a minimum. So in this one, I want us to move step by step again. We start with the intercept, the turning point, that is the stationary point, and also the nature of the stationary point. So we start with the intercepts. We start with the intercepts. The intercepts. Then we move on to the turning point, then the nature of the stationary point. So we start with the intercept. That is, we can start with the x-intercept. The x-intercept, we have seen at this point y is equal to 0. So we simply come and say our equation y is equal to x cubed minus 3x squared. So we equate this equation to 0 because y is 0. So we'll have x cubed minus 3x squared is equal to y, and our y is 0. Then we can factor out the common factor, that is x squared. We have x minus 3 is equal to 0. We want to get the x-intercept and the y-intercept. So here we'll have, therefore, x squared is equal to 0, and therefore x is equal to the square root of 0, that is 0. Again, we have x minus 3 is 0, therefore x is 0 plus 3, that is 3. So we have two values, x 0, x equal to 3. So we need to get the intercept, that is for the value of y when x is 0 and the value of y when x is 3. So we have our equation y is equal to x cubed minus 3x squared. So when it is 0, we are going to have this as 0 cubed minus 3 times 0 squared. We get 0. And therefore in this we get the value of x 0 for y 0. Then again here, y is equal to x cubed minus 3x squared. So our y will be, our x is 3 cubed minus 3 squared. This will be 27 minus, this is 9, again 27. So we have 0. So our coordinates here, we have x 3, y 0. So those are the intercepts, 0, 0, 3, 0. That is the x-intercept.